So guys, in this course, we will talk about NumPy and how to use NumPy in Python. What is NumPy and basically what is the difference between NumPy and Python lists? And yeah, the basic code of NumPy and why do we need NumPy whereas we have list. We can do, we can do matrices and all using list as well. But why do we need NumPy, right? And how to use NumPy in Python. So in this course, we will learn about that thing, okay? So guys, this is the first video of NumPy tutorial, and in this video we will learn about the how to load NumPy, and basically we will learn about the what is NumPy and what is the main difference between list and NumPy, and then we will go on the basic coding section. So NumPy is a fundamental package for scientific computing with Python. So it contains, among other things, like a powerful n-dimensional array. Like if you want to make a 1D matrix or 2D matrix, 3D matrix, and so on, like you can easily make the matrices using this NumPy. And then the sophisticated functions, then tool for integrating C, C++, and Fortran codes. And yeah, that's it. This is the documentation of NumPy, and basically you can obviously use the pandas and all. We will make a course for every module separately, but this course is especially for NumPy. And then now you may ask, like, we can make matrices and all using list as well, but what is the main difference between NumPy and list? So this is the Geeks for Geeks website, and here you can clearly see that the basic difference between NumPy over Python list is that NumPy consumes less memory and NumPy is fast as compared to Python list, and NumPy is easy and convenient to use, right? So now let's see, like, the basic difference between writing of list and NumPy. For example, here is a list called a that is 1D array, obviously 1D 2 comma 3 comma 4, and now there is another list that is assume 5 comma 6, 5 comma 6 comma 7, and yeah. Now let me make another cell for NumPy. So here let's declare a NumPy, and before that we have to obviously load that NumPy. So if you want to load the NumPy, you just need to write import NumPy as np. Okay, now run this cell, and then yeah, now we can use that NumPy. And the NumPy should be write like this because we import as np, so we will write np and dot array, and then inside the parentheses we will write 2 3 4. So I'll just copy it from over here and paste it over here, and then I'll just copy it, copy the whole thing and paste it second time. Then I'll change it to b, and I'll copy this list from there. And yep, now assume if you want to multiply two lists, or you can say two matrices, because these are 1D matrix, so obviously you can multiply both matrices. So in that case, if you use like this, a multiply with b, it will throw an error, because in list you can't, you can see over there it's just type error, because you can't multiply sequence by non-integer of type list, right? So you cannot multiply two lists, but you can multiply two NumPy array. So for that I'll just write over here a into b, and now if I run this cell, now you can see it multiplied both the arrays, and now the actual value of the result is 10, 18 and 28. You can do it on your paper and pen as well, but yeah, this is the way, this is the actual difference between list and NumPy. We obviously use NumPy because it is fast, convenient and easy to use. So yeah. Now let's see the basic applications of NumPy. So the basic applications of NumPy, like you can obviously use mathematical mathematical operations using NumPy. For example, if you want to do matrices and all, it is really easy to use NumPy. And the second one is plotting. If you want to use matplotlib module, and if you want to plot some graphs and all, in that case NumPy is really helpful. And third application is machine learning, because in machine learning you obviously use the TensorFlow, and tensor library is kind of similar to the NumPy, so knowing NumPy will really helpful to use a TensorFlow and all. And the last one is backend. For example, if you want to use pandas and all, in that case also NumPy is really helpful. So now let's see the basic coding of NumPy. Now, before writing the fast NumPy coding, basic NumPy coding, whatever, you first of all need to import NumPy. And if you don't have, if you didn't install NumPy in your device, you just need to go into your terminal over here, and then just write over here pip install NumPy, pip install NumPy, and then click enter, and it will install the NumPy on your device. But for me it is already installed. You can see over here that requirements already satisfied, so I don't need to install it again. And then you can obviously import that NumPy as NP, because we don't need to write a NumPy every time whenever we call it, so we will make it shorter, and that shorter term will be NP. Okay, so now to initialize a NumPy array, we already saw that you have to use np.array. So for first one-dimensional array, you just use this one, like a is equals to np dot array, and that can be like first of all you just need to use a parenthesis, and inside this you can use the list box bracket. So and then we can use 1 comma 2 comma 3, and then if you want to print that, yeah, it will be an array. And in case if you are not using Jupyter Notebook, in that case you just need to write print a, and it will obviously print that particular array. And similarly, if you want to define two-dimensional array, in that case obviously you can write like this, b that is equals to np dot array. For example, this two-dimensional array is a float array, so we will use the parenthesis first of all, and then the first row, right? So this is the first row. For example, this is a floating array, so 2.1, and then comma 3.4 comma 5.6 and all, then the second row. Okay, remember we should divide the two rows with a comma. So here you can see it is a comma, and then we will use another list, the second row obviously, and that is something like 3.9 comma 5.0 comma 7.8 and all. Then if you just print it, let me just print b, and okay, it's a type error. So it is showing a type error. That is because the whole thing is an array, right? So we have to put two rows inside a particular array, that, and for that we have to use the box bracket, right? So we have to put these two rows inside a box bracket, so we will use the box bracket. And now you can see, if I run this cell, you can see it is a two-dimensional array. And let me just write it like this, 5.1, so that, yeah, and I can print it as well, print b. You can see it is a two-dimensional array. So in this way you can declare a NumPy array. Now in case if you want to know the dimension of that particular array, in that case you can just write like this, a dot ndim, and it will show the dimension of that particular array. So here the dimension of a is 1, and similarly here the dimension of b is 2, right? So let me just write over here, this is for get dimensions. Yeah, and now if you wanna see the shape of that particular NumPy array, for example here for b, the shape is 2 by 3, because there are two rows and three columns, right? So for that you can just use this shape command, so shape, and let me just write over here get shapes, and if I run this cell, you can see it is 2 and 3. So the next one is for example, if you want to know that how much memory it is taking for a particular array, so in that case you can use this b dot dtype. And let me just write over get type of the array, or yeah, so it is by default taking float 64, because it by default takes float 64. Obviously we can customize it and initialize with a constant memory location, but for example, if you just want to know the type of a, then let me write over here a dot dtype, and it is taking integer 32, right? It is taking 32 memory allocation, but obviously you can customize it while declaring, because sometimes you don't need 32-bit memory allocation, that is actually equals to 4 bytes. So you can obviously initialize with like int 8, and that will be 1 byte. Yeah, you can obviously customize that thing. So if you want to see the size in bytes, so in that case you can use item size, and let me just write over here get size of the array, and it will show me obviously 8 because 64 is like 8 byte. And if I use this item size command over here, it will be obviously 4 byte. A is taking 4 byte memory allocation, so a dot item size, and it will be 4. But obviously you can customize it. I already told you that. So to customize that thing, you just make it over here like a comma d type. Like after declaring the list, you have to write d type inside the parenthesis. Remember that thing, you have to write d type inside that parenthesis obviously. And d type equals to, for example, if you wanna make it integer 8, that means 1 byte, int 8. So obviously it will create a particular constant memory allocation. And then if I run these two cells, you can see now it is int 8, and it will be 1 byte memory allocated, and that is 1. And yeah, you can see for item size it is 1, right? So it is taking 1 byte memory. And now if you want to see the total size of that particular array, so in that case you can use b dot size. So this will be the total size of the array. It is actually 6. So actually the total size will be like b dot size multiplied with b dot item size. So I'll just write over here b dot size, sorry, yeah, I'll do it over here, b dot size multiply with b dot item size, and that is actually 48. It is taking 48 bytes, and you can obviously do it b dot n bytes, so it will show you the number of bytes it is taking, n bytes. And let me just write over here total size of the array. This is part 2 obviously, so I'll just write over 2, sorry, yeah, 2, and it will obviously show the same amount because b dot size multiplied with b dot item size is the total size of that particular array, and that is equals to 48 bytes. So yeah. So now let's see how to access a particular element or particular row or column from array, right? So before that, I just need to make another array, that is assume C, and that contains, for example, mm, 2 rows of 8 elements. Okay, so 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8, and then we have to make it another row. For that, I'll just write over here 9 comma 10, sorry, 10 comma 11 comma 12 comma 13 14 15 and 16, right? And we also need to put everything inside the box bracket. So yeah, so now if I just print C, okay, we have to print like this, print C, and now you can see this is a 2 row 8 column matrix. And for example, if you wanna also know the shape of this matrix, so C dot shape, and yeah, you can see it is a 2 row 8 column matrix. And now if you assume, if you want to get a particular element from that matrix, for example, if you want to get this 7 from this matrix, so first of all we need to write the row. So I'll just write over here get the specific element. So the syntax is actually, first of all we just need to write the row and then the column. So let me just write over here C, and in the box bracket we first of all need to write the row. So 7 is in the row 0, right? 0 and 1 obviously, so 0, and then the column name, so 1 2 3. Obviously the numbers starts with 0, so I just count it from 0 0 1 2 3 4 5 and 6. So this is 0 comma 6 element, right? Now if I press enter, you can see it is saying that at that particular position the element is 7. Similarly, if I make it 1, then it will show 15, right? So yeah, it is showing 15. So in this way you can get a particular element. Now if you wanna get a specific row, so get a specific row, in that case you have to write like this C, and then in the box bracket the first thing is the row. Obviously we saw over here the first thing is row and the second one is column, right? So if you want to get all the rows, in that case you have to write colon, right? But before that I just need to separate the row and column. So the first this particular section is for row and this particular section is for column. So if you want to get all the rows, in that case you will use this colon. And if you want to get all the rows and columns as well, in that case if you need to write colon two times, because this is for all the rows and this is for all the columns, right? If you hit on this cell, you can see it is printing all the rows and all the columns. For example, if you want to get to if you want to print the first row, in that case you just need to write C0 and then all the columns, because we want all the columns of the first row, so it will print the first row with all the columns. Similarly, if you wanna print the all rows of this third column, like 3 and 11, if you want to print that particular columns, in that case we want all the rows, because there are two rows, and then the column which you want to print. For example, we want this third column, so we'll just write over here 2, and then it will print 3 and 11, because you can see in the third column it is 3 and 11, right? So similarly, if you want to see multiple columns or multiple rows, in that case also obviously you need to use a box bracket. For example, if you want to print 3, 4, 5, this particular column, like third, fourth and fifth column, and all for all rows, so in that case you just need to write C in the box bracket. First of all, we have to mention the rows, so we want all rows, right? And the second portion is for column, so we want only that third, fourth and fifth column. So we will use this box bracket, and here we will just write 2 comma 3 comma 4, right? So if I run this cell, it will print third, fourth and fifth column, 3 11, 4 12 and 5 13, right? So in this way you can get a particular row and a particular column. So I'll just copy it from here and I'll just add one more cell, and there I'll just paste it and rename it column. Yeah, so in this way you can get a particular element, row or column. Now let's see how to change a particular element. One more thing, like before that we want to see one more way to know a particular row and column. That is the fancy way. I just write over the fancy way to to know a specific element, row or column, right? So that is nothing but you just need to, like, here we are writing where is that? Yeah, here we are writing a particular the number of columns which we want, like second column, third column and fourth column. So we don't need to write every particular column manually if those columns are like in a way, so in a particular way. So for example, if the first one is the start index, and then the second one is end index, and the last one is the step size. For example, if you want all the rows, then you will just write 1, and if you just want to skip one row, in that case you need to write 2 and so on, right? Step size. So let me just show you one thing. So for example, here from this particular matrix, we just want to print like 2 to 6. Okay, so we want 2, 4 and 6th column. Okay, so it should print 2 and 10, then 4 and 12, then 6 and 14. We want to skip one element in the way of that particular row, right? So we will just need to write C, and then because we want all the rows, so we will just need to write colon and then comma. Now we are into the column section, so here we just need to use the box bracket, and or you don't need to write box bracket as well. You just you can write it directly as well. So for example, we want 2, 4 and 6, so it starts with second column, right? So the position of the second column is 1. So first you can see the first of all we have to write the start index, so that is 1, right? And now we have to write the ending index. So here the end index is 6. So because we want to write the end index, so we will just write over here 6. Okay, now the step size, we want to skip one element, so we want to directly move to the second next element, right? So after 2 we want to move to the 4 and then 6, so we will just write over here 2. Okay, now if I run this cell, it is printing that thing. Okay, 2, 4, 6, and then 10, 12, and 14. So in this way you can print particular rows and columns. So this is kind of fancy way. And now let's make some changes. Like if you want to change a particular element from that array, so I'll just write over here print C as well, because we don't need to look upward every time. So here suppose we want to change this 14 with 20. So for that we have to first of all get that particular element. So we already saw that if you want to get a particular element, we just need to write the variable name and then the box bracket row and column. So we will just write over the C, and in the box bracket the row is 1, because the index of row, second row is 1, and then the index of column, particular column. So here the index of 14 is 0 1 2 3 0 1 2 3 4 5, so it is 5. And now let's make it 20. Okay, so it is equals to 20. And after that if I print C, you can see now this 14 has been changed with 20, right? And similarly if you wanna like change multiple elements, so in that case you can use this way. Like if you want to get a row and particular column, so we will use that kind of way. So for example, if you want to change this 3 and 11 with for 20 or 40, it's like 30 and 40. Okay, so we want to change this 3 and 11 with 30 and 40. So in that case we just need to write C, and that is, first of all, we want every rows, right? So we will use colon and then comma. Now we are into the column section, so we want this particular column. So this is actually 0 1 and 2, so this position of the index of that column is 2, right? So that is equals to, we want to change it with 30 and 40. Obviously if you make it a single number, it will change it with everyone. So if I print C, you can see the second column is now changed with 30 and 30. Now if you want multiple changes, so in that case you can use a box bracket, and in that first value is 30 and the second one is 40. So the first value will change with 30, and the second value of the second row will be changed with 40. So if I print C, now you can see the first one is 30 and the second one is 40. So in this way you can change the elements from a row and columns and all, right? So now in this video we will see how to make a three-dimensional matrix. For example, we already saw that how to make a 1D array and 2D arrays, because these are the 2D arrays, right? So now we will see the how to make a 3D array. So before that I need to show you one more thing. Like if you wanna make a matrix of a particular range, like this one, like where is that? Yeah, like this one, this is from 1 to 16. So if you want to make this kind of matrices of a particular range, in that case we can use that arrange method. Okay, so for example, let me declare a D, and that will be like np dot arrange. And for example, we want a matrix of 20 elements, so we will just write over it 20. Okay, now if I print D, it will make a matrix of 20 elements that starts from 0 and till goes to till 19. So now if you want to make a reshape of it, for example, if you want to make it like 5 by 4 matrix, that means it has 5 rows and 4 columns. In that case you just need to write dot reshape shape, and in the parenthesis we have to write the row first, that is assume 5, and then the column number of columns, we want 4 columns. So that will total contain 5 multiplied with 4, that is 20. So that's perfect. And yeah, now if I run this cell, now you can see it is a 5 by 4 matrix with the range of 0 to 19, right? So in this way you can create this kind of this kind of 2D matrices. By the way, now let's make a 3D matrix. So E equals to E is the variable name, by the way, and that is np dot array, and that contains first of all you have to use the first box bracket, and inside that we have to put a second box bracket, so that will contain another box bracket, because we want 3D matrix, so we will use 3 box brackets. So assume here we will write 1 comma 2, and then outside of it 3 comma 4, and then outside of the second box bracket this is actually the second row, so this is actually our first row. Now we are writing the second row, right? So here assume 5 comma 6, and then 7 comma 8, and I guess yeah, that's fine. Now let's just print E. Okay, then built in error. Well, yeah, we have to put everything in the parentheses. We already learned about that, so we will need to put a parenthesis over here. So if I run this cell, now you can see this is a three-dimensional array. You can obviously make this kind of arrays using this method. For example, this is a f, and that will contain in p dot arrange, and assume it contains 8 elements, and that will reshape with the number of rows. That means the number of x-axis is assumed 2 comma 2 comma 2, that means x, y, and z, because this is a 3D matrix. Now if I print f, okay, it is an error. Okay, yeah, I put a double R, actually this is a singular. So yeah, now you can see this is a similar one. So you can obviously make a range matrix using this method as well as using this method, but do remember that the first one is the x-axis, then the y-axis, and then the z-axis. So that means we can obviously use this kind of methods to know a particular row or a column, a particular element. So for example, if you wanna get a particular row, or you can say a particular column from the matrix, for example, we want this 3 4 and 7 8. Okay, so in that case we just need to write E, and in the box bracket we want all rows. So we will just write a colon and then the number of y-axis. So we want one y-axis because the first one is 0 and the second one is 1. So we want 1 from the first row and 1 from the second row. So we'll just write over 1. And then for z-axis we want all the z-axis, right? So now if I run this cell, you can see it is printing 3 4 and 7 8, right? So now you can play with these all methods. For example, if you want to change it with 0, it will print 1 2 and all, right? If you just write for a 1, it will print like this. So you can play with it, make some changes and see what is the actual output. So yeah, now let's see how to replace a particular element. Replace a particular element or particular elements. Okay, so this cannot be a singular one, so I'll just write what a replace. And yeah, so for example, if you want to replace this uh, 3 4 and 7 8 with assume 11 12 and 13 14, so I'll just write over here E, and and then colon comma 1 comma colon, and then that will be equals to box bracket, and inside this box bracket we have to write first elements, so 12 comma 13. So that means that this 3 and 4 will be changed with 12 and 13, and the 7 and 8 will be changed with 14 and 15. Okay, now if I print E, you can see this changes. So yeah, that's it for this video. This is for 3D matrices, and now we will see how to initialize different types of arrays. Okay, now let's see how to make different types of arrays or matrices, whatever you say. For example, you already know about the zero matrix. That means all the elements of that particular matrix is 0. So in that case, you just need to write np dot zeros. That's easy. Okay, so before that, let me just make it a comment like this is all zeros matrix. Yeah, now I'll just write over it np dot zeros, and now if I run this cell, okay, it is showing an argument. Obviously it will need one argument, like how many rows and how many columns it needs. So in case if you want one rows with one column, so for that I'll just write over 1, and it will print one row and one column, that is 0. And similarly, if I write 2 comma 3, it will be 2 rows 3 column. Okay, yeah, for multiple arguments, you have to put it in the parenthesis because it's actually take one argument. So if you put everything in one parenthesis, that means the overall thing will be the one argument. So yeah, now if I run this cell, that will be 2 rows 3 column matrix. Now if you want 3D matrix, for example, here I can write 2 and it will be a 3D matrix. Now if you are 4-dimensional matrix, I'll just write over here 3 again and it will looks like this. So you can play with this. So for example, I'll just remove these 2 and make it assume 5, 3, and this looks like this. Similarly, if you want to get all ones matrix, so I'll just write with all ones matrix, and for that you just need to write np.ones. Okay, that's it. Now similarly, like above, it will also take one argument. So if you wanna make it multiple rows and columns, so for that you just need to use another parenthesis and then 4, 6. This will looks like this. Okay, 4 rows and 6 columns. So this is so easy to use Numpy to make different kind of matrices. And now assume if you wanna make a matrix with a constant number, for example a number 90 for all the rows and columns. So I'll just write where all constant number matrix. So in that case you just need to write np.full. Okay, so then in the first argument you just need to write the number of rows and columns it will take. So for example 2, 3, and in the second argument you just need to write that particular number which will contain as the element of that particular matrix. For example, if you want 90 as all the elements of that particular matrix, and then run this cell, you can see it, all the elements is now 90. And obviously you can also set the data types in all the all the methods, for example np.zeros, and if you want to make this data type int 32, and obviously you can do that as well. That will not make any kind of changes. Okay, now for full method, if you have already a particular matrix, for example we have uh, this matrix C. So if I just print C, you can see this matrix has 2 rows and 1, 2, 3, 4, 5, 8 columns. Okay, so it has 2 rows and 8 columns. So if you wanna make a full matrix like this one, like a constant number for every elements, so if you wanna make a full matrix with a constant number in this shape, let me print the shape of it. So yeah, the shape is 2 by 8. So if you wanna make a matrix with this shape, in that case you just need to write np dot let me just comment it as well, uh, full like matrix. So I'll just write over here np dot full like. Okay, because it will be similar to that shape, particular shape. So full underscore like, and then in the parenthesis we have to put that particular variable name from which you want to get the shape. Okay, so we'll just write over a C, and then the number which you want to the constant number obviously. So for example, if I make a 25, and now if I print this thing, you can see that the shape of this matrix is similar to the shape of the matrix of C, and on all the members, all the elements of this particular matrix is 25, right? So now let's see how to use that random module with NumPy module. You don't need to import random module again, because in NumPy the random module is already exist. So you don't need to import the random module again. So I'll just write over here random decimal numbers. And for that, suppose if you wanna make a random matrix of 0 to 1, so in that case you just need to write np.random.rand. You can obviously go into Google and search for random module in Python, and then just click on the first documentation, and there you can find all the methods and all functions. For example, we're using let me search that rand. I'm not able to find it over here. Let me search for decimal. I don't know, actually there is one method called rand, and that will actually print print the random values between 0 and 1. That means it will come with a float type. So np dot random dot rand, and then we have to write the shape of that particular matrix. For example, if you want to shape 3 rows and 4 columns, and then it will print a 3 rows 4 column random value of 0 to, of the numbers between 0 and 1. So yeah, in this way you can use this one. And similarly, if you wanna copy a shape from another matrix, for example, this C has a shape of 2 and 8, 2 comma 8, and so in that case you just need to write, for example, I'll just copy this one, and random decimal number of a constant shape. Okay, so in that case you just need to write np dot random dot random shape, sorry, sample. Okay, now in parentheses we have to put the shape of that particular matrix, so we'll just need to write c dot shape. So now if I run this cell, now you can see it is a 2 by 8 matrix with random values between 0 and 1. Okay, now if you wanna print random values between integers like 1 to 7 or 1 to 8 and so on, right? In that case you just need to write randint, right? We already saw over here, let me search it also, randint. Yeah, so you can see this is a function for integers. We have to put two arguments, so we will use this np dot random dot rand int, and the first one will be the, you know, the number till which you wanna make the random values. For example, we want 15. Okay, so it will make a random values between 0 to 15. Okay, and then we have to put the size of that matrix. So we want a size of assume 4 by 3, so we have to write 4 comma 3. Okay, now if I run this cell, now you can see this is a 4 comma 3 matrix, and it has all random values between 0 and 50. Okay, now in case if you don't wanna make this random integer value starts with 0, in that case you can obviously set the starting point as well. For example, if you wanna set it from 10 to 15, it will make random values between 10 to 15, and the matrix size will be 4 by 3. So you can see now the values of the particular matrix is between 10 and 15. So if I run this cell again and again, the values will be changed because these all are random values, right? Yeah. Now if you want to make a diagonal matrix, so I'll just write over a diagonal matrix. Before that, I just need to write it over here like this is a random matrix with integers. And remember, integer means the negative number as well as the positive number, so you can obviously say this one minus negative numbers as well, right? To minus 4 to assume 5. So this will print with minus values as well. So now let's see how to make a diagonal matrix. So to make a diagonal matrix, obviously all the diagonal matrices are square matrix, so it will obviously take one argument, that is the number of rows and columns both are same, because square matrix means the rows and columns are same. That means we cannot put 4 rows 3 columns and something like that. We want 3 by 3 matrix. So to make a diagonal matrix we have to use np dot identity. I don't know spelling, yeah, identity, and then it will take only one argument, and that is assume 6, and this will be a 6 by 6 matrix with diagonal matrix. That means all the elements are 0 except the diagonals, and the diagonal values are 1. Okay, so if I run this cell, now you can see all the values are 0 except the diagonals, and the diagonal values are 1. And now assume if we wanna make a repeating array. Okay, for example, if the row 1 contains 1 2 3 4, and then if there are 4 rows 3 rows 5 rows whatever, all the rows will contain the same number. Okay, so let me just make it a markdown. Yeah, I want to say like this, this will be like this 1 comma 2 comma 3, and then 1 comma 2 comma 3, and it will continue, assume 2 more times. Yeah, we want a matrix of same content of every rows. Okay, so in that case we just need to use let me delete this one. Yeah, let me just write over here repeating rows. Okay, so let me declare it with f, and f is equals to np dot array, and that is okay 1 comma 2 comma 3 comma 4. And now if I print f, it will look like this. Okay, it is a single dimensional array. So we want this row will be copied for 4 times. Okay, we want 4 rows, or you can say 5 times. We want 5 rows of same content. Okay, so we just need to make this variable f1, and that will be np dot repeat. Okay, and it will take first of all the matrix name, and in this case it is f, and then the value, how many times it should be repeated. For example, if we want 5 rows, so I'll just write word 5, and then x is 0. Okay, so now if I print f1, it will be like this. Okay, 5 rows of same values. Okay, see, if I just make it x is 1, now let's see, it is a one dimensional array. Okay, so we want x is equals to 0. So yeah, in this way you can make a repeating matrix. So yeah, that's it for like different types of matrices. Okay, I can't remember anything else. I think this is all types of matrices. So guys, now it is time to do our first exercise on NumPy. So you can see this matrix, right? So all the side elements are 1, then all the elements over here is 0, and the center element is 5, and this is by the way a 5 by 5 matrix, and you have to make it using the methods we already learned about. Okay, so you cannot use any other methods, you just need to use these methods. Do it by yourself, and after finishing your work, just come here to see the actual answer. So now let's see how to make this kind of matrix. So think properly. Okay, so this is a 5 by 5 matrix, and if we make all the elements of ones, and then if we make another matrix of all the elements of 0, and then we can just replace that small matrix with that bigger one. So let's do that. So S1, or I can say M1. Okay, this is the first big matrix, that is a 5 by 5 matrix, and that is nothing but the np ones. Okay, ones, and it is a 5 by 5 matrix, right? So now if I just print m1, so now you can see it is a 5 by 5 matrix with all the value of ones, but you can see it has this floating value 1 point, and everywhere it is showing 1 point. So we just need to change the type. So dtype is equals to int 32. Okay, now it contains all the integers, right? So after that we have to make one more matrix. Let me just write with print m1. Yeah, so now let's write the smaller matrix, that is the 3 by 3 matrix that contains all zeros. Okay, so you can see over here this is a 3 by 3 matrix and it contains zeros. So m2 is equals to np dot zeros, and this is a 3 by 3 matrix, and the data type is also an integer, right? The data type is equals to int 32. So now let's just print m2. Yeah, so now you can see it is a 0 by 0, sorry, it is a 3 by 3 matrix with 0 value, right? So now we also need to change the center value of this matrix with 5, because you can see over here the center value is 5. So we will just use this one m2, then the box bracket 2 comma 2 0 1. Yeah, okay, 1 second, it is 1 comma 1, 1 comma 1, and that is equals to 5. Now let me run this cell again. Now you can see the center value is changed with 5, and this looks perfect. Now we just need to interchange this small matrix with these values, like sorry, this center values. Okay, so for that we have to change the value of m1, like we have to interchange the center values of m1 with m2. So we will just write over here m1, and you can see over here we have to change the values from 1th position, like 1th column to 3rd column, and similarly from 1th row to 3rd row, right? So we have to change it like this: 1 colon 4, and again comma 1 colon 4. Okay, and that is equals to nothing but m2, right? So now if I just print m1, you can see this is the output. Okay, so now all the center value is changed with 0 0 0 and with this matrix, this particular matrix, right? So let me just delete these matrices, I mean commenting this print statement, and the actual output is this. So this looks similar to this. Yeah, so in this way you can make this kind of matrices using the methods which we already learned. Okay. Now in this video, we'll learn about how to copy one matrix to another matrix. So you may think like, what's big in it? We can just initialize on one array. For example, let me just go up and just copy this one, A, and I'll just rename it with G, and that will be nothing but values of A, and I just need to remove these things. Yeah. So for example, now there is a variable h, and that is equals to z, and that's it. You guys think this is all, right? So if I just print h, you can see it is also printing 2 3 4. If I want to make some changes over here, for example, if the first element is equals to assume 9, then it will be okay. One second. Well, yeah, we have to make it np.arrays. Okay, np.arrays. Okay, actually this is a 1D array, so we don't need to write two values. We can just write over here 0, so because we want the first position, like 2 should be replaced with 9. So yeah, now you can see it is 9 3 4. But when you print G, let me print G, and you can see G is also changed, but we copied H, like G to H, and we already only change the value of H, but it will automatically change the value of G as well. So this is the main problem. If you do like this, you just need to use the dot copy method. So if you write over here dot copy and then parentheses, and then if you just change the value of assume this 3 with 7, and then yeah, if you print G, it will not change. It is 2 3 4. But if you print H, it will be changed. Okay, 2 7 4. Okay, so you have to use this dot copy method. Now guys, let's see how to do mathematical operations on matrices, because we all know if in matrices we can add a particular number to every elements, and then we can add or subtract two or more matrices, and similarly we can multiply matrices. So if you don't know how to multiply matrices, that is kind of tricky, so you should learn that first, because we cannot multiply all the matrices with each other. We should multiply like a 4 by 1 matrix with 1 by 4 matrix. That's kind of rule, and that's tricky. Before that, let me just declare one more variable, that is assume x, and that contains np dot array, and then here 1 comma 2 comma 3 comma 4. And now if I print x, it will be a 1D matrix with 1 row and 4 column. And yeah, if I just add x plus 4, you can see now 4 is added with every element of the matrix x. Similarly, we can subtract a particular number, for example x minus 3. Now yeah, and then x multiplied with 2 and x divided with 3. Now it is a you can see 3 is divided with every element of that x matrix, 1 2 3 and 4. So you can also use like this, x plus equals to 2, and okay, we have to print it. So print x plus equals to 2. Okay, we have to print it after this line. So now if I just run x, yeah, now you can see it is showing the similar thing as 5 6 7 8 and 5 6 7 8. Yeah, so you can also use x plus equals to 2, and you can obviously multiply or square a particular matrix, for example x squared, and it will be 25, 36, 49, and 64. That's perfect. So now let's see how to multiply two matrices or how to add two matrices. For example, here is y, and that contain, for example, np dot arrange. Assume we want a 3 by 4 matrix, so there will be a 12 element. So we will write 12, then dot reshape, and then 3 comma 4. We want 3 rows, 4 column, and that should look like this. Print a y. Okay, yeah, again a mistake, there is one single r. Yeah, so this is a 3 by 4 matrix. Now let's write a 4 by 3 matrix. So I'll just write over here y1, and that will be 4 by 3. So I'll just rename it 4 comma 3, and y1, print y1. Yeah, now you can see this is a 4 comma 3 matrix. So we can obviously multiply these two matrices because this is 3 by 4 and 4 by 3 matrix can be multiplied. So y multiply with y1. Okay, well, it is showing this kind of broadcasting error. That is because if you go into the documentation of NumPy, you can see that this broadcast rule is actually if they are equal shape. Okay, so because we have different shapes, like different shapes, 3 by 4 and 4 by 3, that's why it is showing broadcasting error. In that case, you need to multiply like this, np dot, then the variable name, then the matrix name, okay, y and y1. So let me just save it into y2, and that will be equals to np dot then again dot, and in the parenthesis we have to write the first matrix, that is y, and then the second matrix, that is y1. Okay, so now if I just print y2, you can see now the multiplication has been done. So it is at now 3 by 3 matrix. Quite great. And similarly, if you just let me just print x again so that you can understand properly. Print x. Yeah, so if we just wanna add another matrix, for example x2, and that is equals to np dot array, and that can contain like 7 comma 6 comma 5 comma 4. Yeah, so now if I just write x plus x2, and that will be, yeah, 12, 12, 12, 12. 7 plus 5 is 12, 6 plus 6 is 12, 7 plus 5 12, 8 plus 4 is 12. Yeah, great. So we can obviously add, subtract, multiply multiple matrices, and that's quite fine. Similarly, we can also make a sign matrix or cos matrix, like a sign 0, then sign 30, then sign 45, sign 60, and sign 90. So for that, we just need to write np dot sign, and then the angle of the sign values. For example, if we pass this x, in that case it will make a matrix of like one row, 4 columns obviously, and the values will be like sine 5, sine 6, sine 7, sine 8. So let me pass it x, and then it will print sine 5, sine 6, sine 7, and sine 8. Okay, similarly we can obviously make cos as well. So sine, cos, tan, we can do that. This is the values of cos 5, cos 6, cos 7, and cos 8. Now if you want to get the determinant of a particular matrix, for example, if you don't know how to calculate determinant, let me go into the Wikipedia. You can see over here, to calculate the determinant you have to multiply the diagonals, right? So AD then subtract BC. Okay, so let me just make identity matrix. For example, j equals to np dot identity, and then makes it like 3 rows, and then print j. You can see this is identity matrix. So the determinant of this matrix is 1, obviously, because 1 minus 0, that is 1. So to calculate the determinant, you just need to write np dot lin algebra. All are in short form. LIN means linear, and ALG means algebra. So LIN ALG, and then dot determinant, that is DET, and then the matrix which you wanna get. For example, here we wanna get the determinant of j, so we'll pass j, and then it will print 1. You can see the output is 1. So yeah, the determinant of this particular matrix is 1. So let me just write over here, this is for determinant of a matrix. And similarly, you can also perform other operations in matrix like inverse matrix and so on, right? You can obviously go into this SciPy link. This is for linear algebra. You can see over here. Let me just copy it and paste it over here, so that you can get it from my GitHub repo. And yeah, so this link is now present over here. You can obviously get this uh, Jupyter notebook, and you can click on this link so that you can perform other operations of matrices. Okay, so now let's perform some statistical operations. So I'll just write over here statistics. Yeah, so for example, let me declare a variable called stats, and that will contain np dot arrange, for example, 6 members, like 2 by 3 matrix. This can be 2 by 3 matrix, so reshape will be 2 by 3. And now if I just print stats, you can see this is a 2 by 3 matrix of 2 rows and 3 columns, obviously. And if you want to know the minimum value or minimum element from this matrix, so np dot mean, and that will show the minimum number from this matrix, that is obviously 0. Similarly, we can also see the maximum number from this matrix. Yeah, it is 5. And you can also play with it, like if you want to get the minimum value from each row. For example, here this is 0 and 3. In that case, we just need to write axis equals to 1, and it will show, like in the first row the minimum value is 0, and in the second row the minimum value is 3. And if you make it axis equals to 0, then it will just print the all the members from this particular row, because it will now compare between two columns. So here it will compare between these two columns, these two rows actually. So that means the minimum value of these two rows is 0, and similarly here it is 1 and 2. So yeah, you can see, okay, 1 second. Yeah, here you can see that now the values are 0, 1 and 2. And similarly you can obviously do these things as well over here. So let me just try to it over here. It will be show the maximum row from this particular matrix. So here the maximum row is 3, 4, 5. So it will print this row. So yeah, you can see now if you just make it 1, then it will compare 2 rows. So the maximum value of this particular row is 2, and then the maximum value of this particular row is 5. So it will print 2 and 5. Yeah, you can see. So you can obviously play with these things. You can obviously sum all the elements of from that matrix. So np dot sum, and then pass the matrix name. So here it is stats, and it will print the sum of all the elements from that particular matrix. And obviously you can also use this axis 0 and axis 1 to get the sum of a particular row and column. So guys, now let's see how to reorganize a particular arrays. So for example, in the first case, we want vertically stacked vector, and let me just declare two matrices, that is assume v1, and that contains np dot array, and for example it contains 4 columns, so 1 comma 2 comma 3 comma 4 and 1 row. That's fine. And now let me just copy this one and paste it again. And this is another matrix called v2, and this contains 5, 6, 7, 8, 5 comma 6 comma 7 comma and 8. Yeah, so now if you wanna stack the first one above the second one, in that case you just need to write np dot v stack, and then you just need to write the first row, that is assume v1, and like which matrix will be in the top and which matrix will be in the bottom. So we want v1 at the top and v2 will be in the bottom. So yeah, now we can see 1, 2, 3, 4, and in the second row it is 5, 6, 7, 8. You can obviously paste it multiple times. For example, if you want v2 3 times, then yeah, it will do like this. And similarly, if you add v1 at the end of it, so yeah, it will also do that. So now let's see how to make a horizontal stack vector. So I'll just change it with horizontal. But before starting the horizontal stack, before you should remember that in a vertical stack the number of columns should be same. In case if it contains like one more element, that is 9, then in the first matrix, that is V1, the column is 4, but in case of second matrix the column is 5. So it will not perform, it will throw an error because all the input array dimension except for the concatenation exist must match exactly, right? So this is actually a mismatch. So we will use a exact number of columns in every matrix to perform the vertically stacked vector. Similarly, for horizontal stack vector, we want exact rows of every matrix. That doesn't mean that every matrix should contain a similar number of columns, but it should contain similar number of rows. Okay, so let me just declare a h1, and that will be like np dot let me just write it arrange. So arrange for example 2 comma 4, that means it will contain 8 elements. So arrange 8 and then dot reshape 2 comma 4, oh sorry, 2 comma 4, and then print h1. You can see it is a 2 by 4 matrix with 2 rows and 4 columns. So let's declare another matrix that is called h2, and let's assume it also contains similar rows, because for horizontal stack we want same rows, same number of rows. So it should also contain 2 rows, but in case of columns we just make it 2. Yeah, it is a 2 by 2 matrix, so the number of total elements will be 4. So now if I just print h2, you can see it is a 2 by 2 matrix, and h1 is 2 by 4 matrix. So we obviously can perform the horizontal stack. So to perform horizontal stack, you just need to write np dot h stack, yeah, this one, and then in the parentheses and then box bracket you just need to write the matrix name, so h1 comma h2, and yeah, it will perform this thing. You can see over here, this is till this we have this h1 matrix, and then the last two rows then the last two columns are h2 matrix. Similarly, we can put multiple matrices as well, so you can see over here. Now the third one is actually we already used, that is reshape. Okay, for example, let me just write over here b, and that is equals to np dot array, and then assume this has 2 rows and 4 columns. So we will just write over 1 comma 2 comma 3 comma 4, and for second row we will use 5 comma 6 comma 7 comma 8. Yeah, that's fine. Now let me just print before. You can see okay, name before is not defined, sorry, it is b. Yeah, so 1 2 3 4 5 6 7 8, quite great. Now to perform the reshape, you just need to write, for example, let me just write over a c, and that contains b dot reshape. So there are actually 2 rows, 4 columns, right? The total elements is 4 multiplied with 2, that means 8 elements. So if you want to reshape it, always remember the multiplication of the number of rows and number of columns should be equals to the total element. So here the total elements is 8. So we can perform like 8 by 1 matrix, or you can say 4 by 2 matrix, or a 3-dimensional matrix that contains 2 rows, 2 columns, like 2 x-axis, 2 z-axis, and 2 y-axis. So yeah, for example, let me just write over at 8 comma 1. It will work perfectly because the total number of element will be 8. 8 multiplied with 1, that is equals to 8. So we just print c. You can see this is a 8 by 1 matrix. Similarly, we can do over here 4 comma 2. This is a 4 by 2 matrix, and we can also make it 3-dimensional matrix, 2 comma 2 comma 2, and this is a 3-dimensional matrix. But we cannot put a mismatch, like if I put over here 3, so there, that means that it has 2 rows and 3 columns, but the total element will be 6, but actually there are total element 8. So it will throw an error. You can see the value error, cannot reshape array of size 8 into shape 2 by 3, because it should contain 6 elements then. So yeah, in this video we will learn how to load external files in Numpy, right? So for example, we are over here, so let's open this folder. So in the tutorial folder we have this Numpy, and here let's make a text file. So it can be like, okay, I made a new folder, should make a new text file that can like data.txt, and that's fine. And let me just open it, and let's write some matrices of same number of columns, for example 1 comma 2 comma 3 comma 4. We'll come back after writing all the numbers. Okay, so you can see over here, like we have these 3 rows with 10 columns each. So yeah, now we want to save this file, and let's see over here. You can see it is now saved. And if you wanna get that external file, so we need to write np.gen from text. Okay, so let's do that. np.gen from text. Okay, so now we have to write the text name. So in this case it is data.txt, so data.txt, and then we also need to write like how the numbers will be separated. For example, if you wanna separate every numbers with comma, like these things, you can see all the numbers are separated with commas. So in that case you just need to write a delimiter, and that is equals to comma. Okay, that's fine. Now let's run this cell. Yeah, you can see okay, let me open this one as well so that you can see this thing. So you can see that all the numbers are now over here, and all the numbers are now separated with commas. But there is one problem, that here this is by default a float, right? So to change the data type, you just need to write as type. Okay, so for example, let me just make a file name, like make a variable name. For example, this is file, and that is equals to this thing. And let me just print file as well. So file, yeah. So if you want to change the data type of file, you just need to write file dot as type, then which data type you want. For example, we want integer 32. So yeah, now you can see all the numbers are changed into an integer. Okay, if you want to perform some boolean expressions, then you can obviously do that as well. So for example, now this file contains this thing. Okay, so it is float obviously because we didn't convert it into an integer. So file is equals to this, and then yeah, so now the files are now integer. Then if you just want to know that how many members are greater than a particular number, like for example how many members are greater than 25, in that case it will show the true if the number is greater than 25. So in this matrix it is like 26, 27, 28, 29 and 30 is greater than 25. That means the last 5 elements are true, and except the last 5 elements, all elements are false, right? So let me just write over here file that is greater than 25, and you can see all the members are false except the last 5 elements. Okay, so this is true. And similarly you can also make something less than, like file less than 16. In that case false. I don't know what happened. Let me just rerun these cells. Why it is 25? Yeah, so it's doing perfect. So yeah, if file is less than 16, that means these are true, and except this one, these are false. And now in case if you want to know the values which are greater than particular number, for example here file greater than 25 is the last 5 values, and you want to know the values, the exact values which are greater than that particular number, in that case you just need to write, for example I'll just write over here file, and then in the box bracket file greater than 25, and it will just run, and the output will be the numbers which are greater than 25. So here it is 26, 27 and till 30, right? And the last thing is like, let me just input it again. Yeah, so you can see like if you wanna know the exact index of a particular, sorry, the exact value of a particular index. So for example, if you wanna print 2, 3 and then this 8 and 10, in that case you can just write like this file and then a box bracket and again a box bracket, because the second box bracket will be a list of all the index which you want to get the values. So for example we want to get the value of 2, 3, so that means the position or the index of this 2 and 3 is 1 and 2. So 1 comma 2, and then for example 8 has the position of 7, and then 10 has a position of 9. So it will just print. Okay, well yeah, we have to make it like 0 as well, because we want to know the values of the 0th row, so we didn't mention the row, so that's why it is showing this error. So yeah, it will print 2, 3 and 8, 10. Okay, And you can also perform like conditions for multiple conditions. Like here, this is the first condition, that is file is greater than 25. So let me do it again. So file is greater than 25 is true for the last 5 elements. Similarly, we can use like file is and file is less than assume a 29. Okay, less than equals to 29. So in that case it will show true for 26, 27, 28 and 29. That means last 4 elements will be true, but the last one will be false. Okay, so let me run it. Okay, it is an error. I guess we need to put it into parentheses because these are separate conditions. Yeah, so now you can see that the last four, sorry, yeah, so these 4 elements are true and the last one is false. Okay, so you can obviously put multiple conditions as well. And if you want to make an inverse matrix, for example, in this case, these are false and these 4 are true. But if you want to make all the false into true and all the true into false, in that case you just need to use let me just make it inside one parenthesis, and then we need to use this tilt symbol. Okay, so this tilt symbol, this is above your tab button and under your escape button, I guess, in your keyboard. And if you use this one, it will just inverse all the members, all the elements from that matrix. That means false will become true and true will become false. So if you run this cell, you can see all trues are now, sorry, all false are now trues and all trues are now false. Okay,